ABC and DBC are two triangles on the same base BC such that A and D lie on the opposite side of BC. AB is equal to AC and DB is equal to DC show that AD is a perpendicular bisector of DC. So no, I don't have a clue about how the diagram should be. So one thing is they have the same base. So we need to have a base. Let me do that over here. Okay, that's your BC. ABC and DBC are two triangles on the same base such that A and D lie on the opposite side of BC. So guys, this is BC, right? This is B and C. So opposite side is up and down. Should they be equal? Kind of. No. AB is equal to AC. Okay, so they're telling AB is equal to AC and DB is equal to DC. That's all they're telling. AB and this is D. Show that AD, okay, AD is a perpendicular bisector of BC. Right, so basically this we can call it as point P. My question to you guys is, what is perpendicular bisector? Before answering any question, you need to know what the term is. What is a perpendicular bisector? On to our concept map. So let's look at this. Yeah, it's there under isosceles triangle, right? We have a perpendicular bisector. Okay, if you guys want in bit more detail, I think I have it somewhere. I have it. Perpendicular bisector. Oh yeah, it's here. Perpendicular drawn from the vertex of the triangle to the opposite side. Your altitude or perpendicular. Actually not. They are not perpendicular bisectors. Perpendicular bisectors, I'll add them. Okay, I'll add that. So let me add that. Let me write it off. That is helpful for you guys. Perpendicular bisector. Okay, that will be there when you guys are studying. I'll explain it off. So the idea behind perpendicular bisector is quite simple. We have a line which is making an angle of 90 degree, thus the word perpendicular, and it also bisects the side, that is PB is equal to PC. Okay, and thus we have the perpendicular bisector. So we have to show that AD is a perpendicular bisector. So we have been given that AB is equal to AC and BD is equal to DC, making your angle ABC equal to ACB and making angle DBC equal to DCB. Right? It's obvious, no? This is X, this is X, this is Y, and this is Y. I hope you guys are thorough with this by now. If not, the properties are over here. Yes, we are looking at isosceles triangle. Since the sides are equal, the opposite angles will be equal. So clearly, opposite to this particular side is angle B over here, right? So let me do that for you guys. So opposite to this side is angle B, okay? And opposite to DB is angle, yes, C. Then we have opposite to AB is angle C and opposite to AC is angle B. And so we have this. Okay, so how is that I can make use of this? Well, this is to do with something called as kite. If you guys know about kite, you will be done. Kite is a quadrilateral which has two adjacent sides, two pair of adjacent sides to be equal, right? And the diagonal will bisect each other. So that is one of the ways of doing it using kite. I'll just write it so that you guys can, so we can solve it. Or let me write it over here, note. We can also solve it. With the concept of kite. Okay, yes. So this structure is a kite. By default in a kite, the perpendicular line, right, this line bisect this. Okay, but here we will not use that. we'll use the concept of congruency. How congruency, that you guys can pause and think over. So by that time, let me talk about, no, maybe not congruency also. If I do use congruency, okay, let me think over. So to prove AD is a perpendicular line to BC, perpendicular, and it bisects, and AD bisects BC. Okay, now the proof. So remember, we have to prove that this is a perpendicular line and also bisects. So what can we do? I'm still thinking of it actually. Can we use that property? There's a property regarding isosceles triangle. Okay. So we are joining this line, so we can't take that. So we have to prove this angle is equal to this. This is a perpendicular bisector. Okay, as usual, I'll just write what is obvious to me. So such that, so and so forth. Okay, so in triangle ABC, I'll just write what is obvious to me now. AB is equal to AC. This implies it's an isosceles triangle. AB is equal to AC. This implies triangle ABC is an isosceles triangle, and angle ABC is equal to angle BCA. Okay. Next we have, let angle ABC is equal to X. This implies angle BCA is also equal to X. This is from 1. Right? Then in triangle BCD, we have BD is equal to DC. This implies triangle BCD is an isosceles triangle, and angle, oh yeah, we have to write the reason. Opposite angles of equal sides. Opposite angles of equal sides. And here also we have angle DBC is equal to angle DCB. So we have opposite angles of equal sides. Okay, we'll call this as let angle DBC be equal to X. This implies angle DCB is also equal to, not X, sorry, Y. Okay, now on to proving that this is a perpendicular line, perpendicular bisector. So basically I think, yeah, we have to prove that these two triangles are congruent. Okay, so we have, since these two triangles are congruent, these two angles will be equal, and so they will be 90 degree, and also BP is equal to PC. Basically, yeah, that's the whole funda. Let me explain it to you guys. So till now I didn't understand how exactly we have to go about doing this, but now I'll show you guys how we can do this. So very first thing is, we have to consider, oh, that didn't work out. First triangle ABP, I'll explain it slowly. Okay, and another triangle is your APC. Right? So you can clearly see that these two triangles are congruent. How? Think about it. What do we have? We have one side which is equal to another side. Okay. Oh, I can't use that. We have one side equal to another side. And what else do we have? We have one common side. Okay, that's good. We need these angles to be equal. But how will we prove that these two angles are equal? See, the point is we have to prove that at point P, right, AD bisects BC and also it is perpendicular. For proving that, if I prove that these two triangles are congruent, then I'll be able to prove that these two angles are 90° and BP is equal to PC. That's how we can do it. But the question is, how will we prove that these two triangles are congruent? We have two sides and a common side. But what about the angle? This angle, somehow we have to prove that they are equal. How will we do that? For this, we have to go a bit extra step. Take a bit of extra step. That is, we have to consider triangle ABD as a whole. Okay. And at the other end, we have ADC as a whole. Okay. So these two triangles, if I consider, I can tell that these two triangles are congruent. And so angle BAP is equal to PAC. And then prove the other set of triangles and so on and so forth. It's a bit lengthy. The sequence of thinking is a bit long. But yes, this is your answer. Okay. So that's the only way we can go forward. Right, guys. So it was not clear to me until and unless I started discussing with you guys and started explaining it to you guys. Okay. So first thing is in triangle. Don't worry if you're not understood. As and when we write, we will understand it. ABD and ACD. Okay, these two triangles. Right. So just for our reference, we can have this. I'll do this for our reference. It'll be easy. Yeah. So between these two triangles, we have AB is equal to, sorry, I should write this here. AB is equal to AC. Then we have BD is equal to DC and AD is common. And these two are given. Okay. Therefore, by SSS congruency, triangle ABD is congruent to triangle ADC. Agree? Okay. And with this, by CPCT, I can tell by CPCT, we can tell that what can we tell? Angle BAD is equal to angle DAC is equal to angle DAC, right? And with this information, I can prove these two small triangles are equal. Okay, guys. So let me, yeah. So there is one more thing that I have to write actually. Let P be the point of intersection of BC and AD. Okay. And now we have to consider, let me change the color. Consider triangle, oh sorry, just a second, I need to clear this. Yeah. Consider, what are the triangles? Let me show it to you guys now. ABP and ACP. ABP and triangle ACP. So what do we have? We have BP is equal to AB, not BP. AB is equal to AC. Okay. Then we have AP as common. And we have angle BAD is equal to angle DAC. Okay. And this implies triangle ABP is congruent to triangle ACP by SAS criteria. Okay. And now we can tell by CPCT that we have BP is equal to PC. BP is equal to PC. This implies P is the midpoint. Okay, that is basically we are telling what is that? AD is bisecting BC. This in turn implies AD is bisecting BC. Okay, correct? What is it? Yeah, BC. I think I don't. Oh, I do. I don't have much space. Then the next thing is also by CPCT. By CPCT, we have angle BPA is equal to APC. BPA is equal to angle APC. Okay, so I'm calling them as let angle BPA is equal to, let it be equal to x. Therefore, angle APC is also equal to x. Right, guys? And now on to the next step, that is angle BPA plus angle APC is equal to 180 degree. Why? Because they are linear pair. Is it not? So linear pair is what? Linear pair is this, right? Angles on a straight line. So in place of those two angles, I'll write x and x. Does it not make sense? Because we are already calling it as x. We just called it in the previous step. Okay, so these two angles I'm calling it as x. I know in this diagram I have written something else, but let me erase that. That's not required actually now. If you already taken it as x in your diagram, you can take this as a, not an issue. Okay, so therefore x plus x is 2x, so x is equal to 90 degree. And thus at last this implies AD is perpendicular to BC. Okay, and hence proved. Okay, yes, this is I think the lengthiest writing in this section, but that's your answer. So we had to go 2 steps. Again, this is just a single statement when it comes to using your concept of kite, which is a quadrilateral, by the way. It's just a single line. It's a fact for a kite. But yes, we have to prove this. You know, you can't just, I don't know, I mean, not I don't know, we can't do that. So this is basically a 3 or 4 marker question. I hope this is for 4 markers, but yeah, it's not that they can't give it for 3 marker. Technically, I mean, this is a bit long question. They have to give it for 4 markers. Okay, understood? So what did we do? First thing is we just wrote the obvious. First the diagram, obviously. And then we marked and stuff. And yes, I spoke about the angles being equal also. But in this case, it was of no use. But it's okay. So end of it, we had to figure out that, you know, BP is equal to PC. And that angles, right, over here, make an angle of 90 degree each. So for that, we had to prove congruency between triangle ABP and ACP. For that, we needed this angle. Now, without this, we can't do much. So how is that we handled that? We took up the entire triangle over here, which was congruent because of SSS. I hope I wrote it right. I think I wrote it as what? Where is it? Yeah, SSS only. That's correct. And this is SAS. Okay, I thought I missed it out. Okay, no issues. It's correct. So these 2 angles are equal, and thus we have this 2 set of small triangles are congruent, proving whatever we want to be proved. Okay, so again, it's a bit of writing, but the sequence of thinking is not too difficult. At least that you guys can agree, right? Again, please take away the fear that maths is difficult. Maths is a well-organized, systematic way of thinking and doing, right? You guys have to just get used to it. And yes, obviously we need to know the properties and remember it. You know, there are a lot of things that is linked. I can't use only one sheet and tell you all of it. And now I have to create a bit extended version of this, you know. I need to add one more sheet as well. There are quite a few things actually. One sheet we won't be able to fit it. There are quite a few more things, that terminologies and all of that. It will help you guys because you guys miss those facts out, perpendicular bisector, you don't know what does that mean. So all of those I'll try to give an example. Right guys, again please, I'm making it all as organized as possible. It's your duty to make use of it in that way. Don't mess it up. Don't do last minute studies. Okay, the thinking has to change, right, for maths to become simple, and it takes time. So give that time, only then it becomes simple. No amount of teaching or no amount of just listening will help you guys. Yeah, okay, now you can pause and have a look at the answer.